Plane. All right, did you start us? Okay. Inclined plane, we're just going to take a few notes. The inclined plane is one of those topics that every physics student and every beginning physics class in the world studies. The inclined plane. So this is your moment of moments. Okay. All I'm going to establish today is the forces that are at work on an inclined plane if I get that far. So we'll pick it up tomorrow. We'll just go as far as we can till the bell rings, which is 5 minutes away. Draw an inclined plane with an object. I picked a box on it. And this inclined plane makes an angle with the floor. So I'm going to call that angle theta. So if you would set up your inclined plane like that, there is a force from this box, and it's the weight, but it's kind of different when your floor is slanted than when it was flat. The weight still goes straight down toward the ground like this. So the weight goes downward. So I'll stop it right here so we don't crash through anything. So the weight is downward. So I'm going to label it weight, and we also know that weight is mg, but I'll call it weight. I desperately need colored chalk for this one. Let's see what I can find. Actually, I saw some back here. I don't know if it'll show up on the board. It's rose art, so sometimes they're inferior. Oh, they're crayons. Okay. I guess I'm stuck with all yellow. Sad. Sad but true. Let me just check one more place. Here's a little red nub. Sorry if I scrape. Alright. We are going to, just like when we have, this is at an angle to the floor, isn't it? So guess what? We're going to split it up into components, but they're no longer x and y components because x and y are horizontal and vertical, but we've slanted the floor. So we're going to have to make these components perpendicular to the floor and parallel to this floor right here. We'll call it the plane. So one component is going to come down this way, and one component, let's see if I can get, I found a blue nub, is going to go this way. Can you get the components so they're at right angles? This one is perpendicular to the plane, and this one is parallel to the plane. Can you get it drawn like that? I'm going to name them instead of x and y components, which don't count anymore because we've slanted everything. How do you know if this is the x or the y, or this is the x or the y? It's not real clear. So I'm going to call this one the component that is parallel. The parallel component. Parallel to what? Parallel to the surface of the inclined plane. So this one I'm going to call parallel component, and I'm going to call this one the perpendicular component. So when I refer to them, I'm not going to say x and y component. So we recall through some geometry. Let's see if I can tease this out of you. See if I can tease it out of me. When you have two lines that are perpendicular cut by a transversal, do you recall what that does to this angle and this angle? Does anyone recall from the deep past? What, Molly? They are. Those are called alternate interior angles. So these two angles are equal. So I'll put a little check mark there. And this is a right angle. And this is a right angle. Yeah, see any other right angles? So, through this discussion, what must this angle be equal to right here? Can anyone see that this angle here is the same as this angle here? Through a discussion of, which I don't have time to go, tomorrow I'll slow down and show you why, but for now, and beginning that discussion with alternate interior angles, this angle here is the same as this angle of the inclined plane. Very important to our development. All I want to do now is name the components. If the bell rings, let me finish their names and we'll call it a day. This one, I lost my blue nub. It is really a nub. Look at this thing.
Oh my.
Can you see it? All right, the parallel component is across from the angle, and this is weight, so its name is weight sine theta, because sine always works with the side opposite. And the red component, or the perpendicular component, is next to the angle, so it's weight cosine theta. And that's a good stopping spot right there. Thank you. See you later, Jonathan. All right.